Peace be upon you and God's mercy and blessings. God willing, we will talk together about one of the most important tests conducted on circuit breakers, which is the timing test. In order to perform the timing test for the circuit breaker correctly, I need to refer to some data that is written on the circuit breaker nameplate, in addition to some test results that are available in the FAT test or the factory acceptance test. Regarding the circuit breaker nameplate, there is always something written called the operation sequence or the circuit breaker duty cycle, which explains the sequence or the order of operations for the circuit breaker. Close open and open close open. Considering the timing that must be present between the operating cycles, my application now will be on the medium voltage circuit breaker with a spring type mechanism, which consists of two springs, one for closing and one for opening. A video will now appear in front of you, showing how the operating cycles are performed on the circuit breaker spring type mechanism. Let's now understand together what the operation sequence written on the circuit breaker nameplate means, such as 0.3 seconds CO or 3 minutes CO. The first thing is that O represents an open operation and CO represents a close open operation. The second thing is that 0.3 seconds and 3 minutes are delay times, and they are referred to as edit times. The first edit time, which is 0.3 seconds, is simply defined as the minimum time kept for the circuit breaker after an open operation in order to be ready for a successful close open operation. What does this mean? We all know that overhead transmission lines are highly exposed to transient faults, which is why we activate a function called auto reclosure within the protection relay. The idea is quite simple. When a fault occurs on the overhead line, the protection system will issue a command to the circuit breaker to open. This is considered an opportunity, 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 an opportunity. And the fault still exists, meaning the fault is still present on the line. Therefore, when the breaker closes, it must open again almost instantaneously. Here, the breaker indicates that between the first open operation and the close open operation, which is the second operation, there must be a delay time of 0.3 seconds. The second timing is the third timing, or the third timing between the first open, close, open operation, repeated multiple times. Why do I even use it in the circuit? I need it for two things. The first thing is that now with the operations happening in the breaker, like open, close, open, open, close, open, the breaker keeps opening and closing on an arc, passing between the poles of the circuit breaker. This will lead to an increase in its temperature, and with the rise in temperature, deformation might occur in the pole contacts. No, of course, this in turn will lead to bad contact resistance, which could potentially cause the circuit breaker to explode. That's why I need a delay time for the circuit breaker poles to cool down. The second thing is that the insulation medium used in the circuit breaker, whether it's vacuum, SF6, oil, or even air, can recover and regain its strength after the arc quenching process. What does this mean? Let's take an example with SF6 gas. At the moment, SF6 gas interrupts the arc. The passage of the arc naturally leads to an increase in the gas temperature. Okay, the increase in the temperature of the SF6 gas leads to its reduction. That's one thing. The second thing is that with the rise in temperature, the SF6 gas begins to decompose into different components like SF2 and HF, among others. With the temperature dropping again, they recombine, meaning they gather together once more to form SF6 gas again. Consequently, in this state, the SF6 gas is capable of interrupting the arc once more because it has now recovered its strength. After the arc quenching process, we mentioned that's why I need to allow a delay time for this insulation medium, regardless of the type of insulation medium, so it can recover its strength more after the arc quenching process.